Hello students, welcome to Dr. Shoraf sir classes. So in the previous video you have seen that we have solved the question from UPSC. So in this video we are solving the same, that continuing with the same thing, UPSC Maths Paper 2 of 2021. So in this paper we will be solving the last part of the question 1, that is 1E. Okay, so let's see the question. What is the question? Is saying the department of a company has 5 employees with 5 jobs to be performed. The time in hours that each man takes to perform each job is given in the effectiveness matrix. Assign all these jobs to these 5 employees to minimize the total processing time. So these are the employees and the jobs is there. Okay, so these are all the times that is given by the employee 1 to do a job A is 10 hours. The same job by this employee B2 is takes 5 hours, and so on and so forth. So the thing is that we have to assign all the jobs. So our question is assign all the jobs to these 5 employees to minimize the total processing time. Okay, so let's start with this solving. Now what we have this, so let us take this as a matrix form. Okay, so this is given. So what we will do, first of all, we will subtract the minimum element of each row. So this is row 1, row 2, row 3, row 4 and row 5. So in each row we first will determine the smallest element and then subtract this minimum element from all other elements of that row. So in the first it is 5. So what it will be? So we have this 5, sorry, 10 minus 5 5, 5 minus 5 0, 13 minus 5 8, this is 10, this is 11. In the next we have 3. So similarly we have this 0, 6, 15, 10, 3. In the row 3 we have this, the smallest is 2, so this is simple, 8, 5, 0, 0, 0. In R4 the smallest is 7, 0, 4, 2, 0, 5. And the last one, the final one, it is the 4. So we have this 3, 5, 6, 0 and 8. Okay, now this is we have in the first hand after subtracting this thing. Now in the second case what we will do, so we will just subtract the minimum element of each column. Okay, so now this is, okay, let's take this column 1, column 2, column 3, column 4, column 5. So what we will do, the subtract the minimum element of each column from the element of that particular column and cover all the zeros by minimum number of horizontal and vertical lines. Okay, so what we will do, so we have to subtract from here onto, so we have to keep this. Okay, now the next step is, so the first of all the column here it is 0, so we will do the same thing. So it will be 5, 0, 8, 0, 3. Next it is 0, 6, 5, 4, 5. Next we have this 8, 15, 0, 2, 6. Similarly for this it will be 10, 10, 0, 0, 0. And finally we have this on the last hand. So this is going to be 11, 3, 0, 5, 8, right? So in each of these column we have that all the actually the zeros are the smallest element. Now, and the second that important thing that we have to do, we have to cover all the zeros by minimum number of horizontal and vertical lines. So here is 0. So okay, we can do it in another ink. So now here we have 1 0. So this is one vertical line. Trying to make it straight. So this is one vertical line. This is another vertical line, another 0, because we have to cover all the zeros by minimum number of vertical and the horizontal lines. Next is this, and finally we have this, the middle one, right? So this will be the thing, so that you can see that all the zeros are covered by 4 lines only, right? So R is equal to 4, which is less than 5, right? So now 2 is the least uncovered element. Subtract 2 from all, that is, yes, so that is here you can see from this. So 2 is the most uncovered element, least uncovered element actually, and then we have to subtract 2 from all the uncovered elements and add 2 to the elements at the intersection of the covering lines, namely this 8 5 0, okay, 8 5 0, right, at positions 3 1 3 2 and 3 4 respectively, and leave other covered elements unchanged. So what will be the reduced cost matrix then? So let us do it over here. Okay, so then here it will be 5 0 8 minus 2 is 6, 10, and 11 minus 2 is 9. It will remain same, the 0 6, 15 is 13. Okay, and we have this 0 and 1, 3 minus 2 1. Similarly we have this 10, so it is 0 7 0 2 0. In the next row it will be 0 4 0 minus, to the minus 0 comma 3, and the fifth will be 3 5 6 minus 2 is 4 0 8, right? So now in this particular table that we have created, so this is table number 1, the first operation after we have done from this table 0. So this is table 0. So after that we are coming to this table 1, performing these operations. Now after the performing the second operation, this is what you have got is table 2, and this is up to this the table 3. Okay, so in this table cover the zeros by the minimum number of the horizontal and the vertical lines. Okay, so again we have to, so this one, so each of the line will be there because zeros are in each of these row are there. So here you can see that we require exactly 5 lines, right? Exactly 5 lines to cover all the zeros, right? So at r equal to, as r is equal to 5, so here we can see, so r equal to, this is equal to 5 equal to n. So as r is equal to 5 equal to n, okay, then optimal assignment can be made at this stage. This optimal assignment can be made at this stage. So for making this assignment, we will proceed with this thing, that what we will do, first, second and fifth row have only 1 0. Now let us go to this one. Okay, so first, second and fifth rows, okay, have only 1 0. This one, okay, in the second we have this one, yeah, 0 6 3. So sorry, it is 10. Okay, this is not 0. So and the fifth row, this one, here it is only 1 0, right? In the positions, so this is 1 comma 2, this is 2 comma 1. Okay, so this is 2 comma 1, and this is going to be, so 5 comma 4, this. So we have encircled these zeros, and let us cross all the other zeros in the table. So this one, first one, this 2 3 4 5, right? So fifth column contents, now we have this 1 2 3. Okay, so in this particular we have done. Now fifth column contains only 1 0 in position 3 comma 5, right? The fifth column, as you can see, so here it is, yeah, so here it is, this one, this one, this one. So in the fifth column, so this is C5. Okay, so this is the fifth column contains only 1 0 in the position, so this is another 0, that is 1 0 only there in 3.5. So encircle it and cross all the zeros in its rows. There is no other zeros, so this is already we have completed, right? So there is only 1 0 in the fourth row. There is only 1 0 in this fourth row. Okay, so encircle it. So in the fourth row we have this is the row 4. Okay, so I have eliminated this. Okay, so because we have to, so in this column we have eliminated, here this is no nothing over here, so actually this will not get eliminated actually, because here there is no 0 in this particular column and no 0 in this particular row, right? So in this particular row we have only 1 0 left, because these are all cancel out due to this present of this 0 in this column and 0 in this column. So here we will have this, we have this 0 over here. Yes, so here we have this 0 over here, and that we will encircle, and this position, so these are, there are now then these are 4 zeros, we have this 5 zeros we have. So now since each row and each column has a single, now you can see, has a single encircled 0 in each of this row and column, then each row and each column has one and only one assignment. One and only one assignment, right? So an optimal assignment is reached. So what is the optimal assignment? So for the A, okay, let us take this, from this equation you have to find, so from this table, so from this you can find that A, so these are the employees that these are the job actually, A, B, C, D, E, and employee 1, employee 2, employee 3, employee 4, employee 5. So the job A is assigned to employee 2, right? Job B to employee 1, just follow the encircled zeros over there. Job C to employee 5, job D to it is employee 3, and finally job E to employee 4. Okay, so that is the optimal assignment. From the encircled zeros you can easily identify. So the minimum assignment cost is C of 1 2. So this is C of 1 2, then plus C of 2 1, plus we have the second is C of 2 1, then in the C, so this is C of 3 5, this is C of 3 5, right? Now we have this 4 4, this is 4 3, plus C of 4 3, plus C of 5 4, right? Now you do this, so the calculation will be, this is 5 plus 3 plus 2 plus 9 plus 4, so which is equal to 23. Okay, so this is the minimum assignment cost. So that we have find that the total processing time 23, the minimize this total processing time, and we have solved this question number 1e. Okay, so if you have any problem in understanding this thing, you can just write to us. Okay, you can also just find in the comment section, you can also put your view over there. Okay, so in the next video we will solve the question 2 of this paper 2 of 2020. See you in the next video.